A very delightful evening once again to everyone who has joined us today with AI-Driven Sri Lanka. And I hope everyone is feeling comfortable wherever you are as we are ready to kick off things for inaugural workshop of the pre-boot camp brought to you by AI-Driven Sri Lanka. This session is a short session in which we would like to shift your focus towards the introduction of artificial intelligence and machine learning. And we hope all our AI colleagues that are joined today are hyped up to get things started. AI-Driven Sri Lanka is an initiative by IEEE Young Professionals Sri Lanka with the motive of enhancing and widening the horizons of concepts of artificial intelligence among enthusiastic tech colleagues of Sri Lanka. Please note that this is the first pre-bootcamp session and there are 4 more sessions to come afterwards. So please stay tuned with our social media platforms for more information about these sessions. Please keep in mind that if you have any questions related to today's session to be directed to the speaker, please log into our Slido platform through the link that is shared in the chat or scan the QR code that is on the screen. Your questions will be answered during the Q&A session that will commence after the knowledge session has been concluded. Please ensure that your mics are muted at all times and your videos remain off as not to disturb the flow of the event. On that note, let's get started on today's proceedings, as I would like to invite our speaker for today's evening. We, as the AI-Driven Sri Lanka, warmly welcome Mr. Haritha Thilakarathne. Mr. Haritha is a competent and professional with a wide knowledge in the fields of big data and cloud computing, and is an absolute unit when it comes to all matters regarding the subject, and quite a fantastic gentleman to start off our first workshop. Hailing from the University of Rajarata, where he completed his bachelor's degree in information technology, has worked his way up around many circles, sharing his knowledge and providing help towards the development of big data. Calling his specialization in the field, ongoing research for his PhD in deep learning with La Trobe University, Australia, and has been renowned for most valuable professional in artificial intelligence by Microsoft. Sir, it's a pleasure to have you with us in this evening, and the virtual stage of AI-Driven Sri Lanka is yours to commence the pre-boot camp of AI-Driven Sri Lanka.
Thank you, Sandro, for the introduction, and wish you all a very good evening back in Sri Lanka, and good day for all the people who are joining around the world. So for me, it's close to midnight now. So I'll start my sharing. Give me a second. I hope you can see my screen now.
Yes, sir, it's visible.
Cool. So let's get started. So as we have discussed, today's session is going to be the first session that AI-Driven Sri Lanka is going to host within this era. So I have been working more with this IEEE young professionals for quite a good time, and I have seen the good work they are doing for the technical community in Sri Lanka as well as for the student community in Sri Lanka. Kudos for all the organizers. Let's move forward with the session today. So the session that I'm having today is about the introduction or getting started with AI and machine learning. So this is not going to be a deep technical session where we're going to discuss the technicalities inside machine learning and all, but going to do a bit of like a 10,000 feet overview of what machine learning is and AI is. If you have any problems, as mentioned before, you can put the questions in. So we'll answer those questions in the Q&A time. And also, I would say, if you have a question when the session is going on, I'm there on the chat window. So you can put the things on the chat window too. So I'm okay for that. Let's get started. If you have any questions, just ping me and we'll go towards the questions in that time too. Right. So a little bit of me. So in the introduction, they had a big chunk of words of me. So simply, I'm working as a consultant at Arinco. Arinco is the shortened form for artificial intelligence company in Australia. So I'm also a Microsoft MVP in AI category. I do read for my PhD at La Trobe University, uh, focusing in the research areas of computer vision, deep learning, and sports analytics. So that's a brief introduction of me. I did my bachelor's back in Sri Lanka at Rajaratnam University and moved here for my PhD, and now here for quite a long time and doing my stuff here, mostly in the AI, machine learning, and the big data space. Right. Let's get started about this hype word AI or artificial intelligence. If you ask from any of the undergraduate or a graduate who's in this IT or the computer science arena in domain, what is the most used word in their vocabulary right now when it comes to project research or the things like that? It should be AI. No doubt it is going to be AI. But the things we have to keep in mind is AI is not a fiction now. It is not something that we can only read on science fictions or only in the research space. We can see AI has been using and is being using in most of the day-to-day applications that we have and that we have seen. The self-driven cars that we see in Sri Lanka even uh, are using computer vision plus some AI applications to do their autonomous driving. And the things like Boston Dynamics robots, they are using AI technologies to get the decisions. The simple applications like weather prediction, they use machine learning techniques to predict the weather coming by and predict some of the natural disasters that can happen to some extent of accuracy. If you have seen the modern elections happened in the world, mostly in the US. So we can see they are using machine learning technologies or AI technologies to predict the winning capacity, plus to plan the strategies, how the election's going on. So machine learning and AI technologies are conquering almost every field, every domain in the world. So even the Google Assistant or the things like uh, Apple Siri that you have on your phone are using voice recognition, natural language processing, such things, which has been influenced by AI. And so the conclusion that we can take is it is not a science fiction now. It is used in everywhere in our day-to-day lives. So we'll move forward and see what actually this hype is all about, what actually these terms are meaning of. So let's take a look on those things. So I would say AI or artificial intelligence is one of the most brutally harassed word in the tech industry, because that's a very good marketing term that we can use to market some of the things that we have to sell, right? So if you go for any sales pitch a software guy is doing, so they'll definitely tell we are having AI component on that. Or else if you go for any final year research or a project, they'll ask you to do some sort of AI component in your thing, because it is very attractive to have that name or the word in your research or the thesis. But AI is not a new term. It is not a new technology. It got its birth back in like 1950s. People were thinking about machines that can think or machines that can take decisions by themselves, because at that time computers or the computing machines that had in like 1950s and 60s were mostly using analytical or the procedural instructions, and we give some procedural instructions for the machine. It was able to take some decisions or make some calculations upon that. So people are thinking about some machines that can think, and it came up with all the science fictions too. But at that time there was a scientist called Alan Turing, so who introduced the the formal definition of artificial intelligence. If you search a Turing test, you can see how he has defined how to define an AI, and like that can be known as the very first definition of AI and a differentiation of AI from the normal procedural or the sequential computing or the programming paradigms. That was back in like 1950s, and people were thinking how to build thinking machines, how to build machines that can think and take decisions. uh, so they went through the idea of learning things by a human. So they start building up from the idea of learning of a small kid, and then they thought of kids or the humans are learning from experiences, or the experiences they are getting from the environment. Or then how it would be if we can learn from the experiences even from an algorithm. So that gave the birth for machine learning algorithms, which is using the prevailing data or the historical data to learn the patterns and the connections or the relationships between those data and give some output for the future. That gave the birth for the machine learning algorithms, hugely influenced from statistics and mathematics. So that was like 1980s. People were doing predictions based on the past data and the things with these machine learning algorithms. And even at that time, they invented something called artificial neuron, which is not a medical thing. Artificial neuron is kind of like a mathematical interpretation of the neurons that we have in our brain, but it is not that complex. You know, in our brain, we have millions and billions of neurons, but this is just a simple one neuron that has been defined from a mathematical equation. I'll explain in that in my future slides. Then they were talking about those things. And this artificial neurons plus other machine learning algorithms came into the picture from 1980s, and people are doing big experiments as well as some practical applications on that. But the major drawback they were having was the computation power. So in order to do a lot of computations that these algorithms needed, and a lot of calculations that these algorithms needed, it was not able to use the computation power that we had at that time when it comes to 90s and 2000s. Then it came up to the era where the cloud computing came in, and also the GPU or the parallel computing came in. That gave a boost for these AI or the machine learning techniques. People thought of, all right, now we have the parallel computing paradigms. We have the power of cloud where we can do distributed processing of complex applications. So we can use those algorithms that we started building in 1980s and use that thing in a very profitable way in the modern computing paradigms. So that is the thing that gave this boost for artificial intelligence. Obviously, the computing power that we start to getting in, plus people were realizing this is a good way to understand most of the natural problems, as well as to do the predictions for most of the non-linear problems. So like that gave the birth for a separate portion or a chunk in artificial intelligence, which is called deep learning or the deep neural networks. So the final idea that you have to take is machine learning is not the only way of doing artificial intelligence. Machine learning is just only a subpart inside AI, and inside machine learning we have a lot of algorithms. From those algorithms, deep learning or the deep neural networks is just a sub portion of doing machine learning. But deep learning is so much popular because of its ability of understanding human vision and natural language kind of things. So AI is not all about deep learning, or AI is not all about machine learning. So those are subcomponents that I have described here in the slide. Right. So with AI and all, it comes to the term of data science. Everyone is talking about that, and everyone wants to be a data scientist now. So data science, or the area of data science, is a combination of three main pillars, which goes as computer science, mathematics and statistics, and the domain knowledge. If someone is not having a good domain knowledge, he can't be a good data scientist and can't use the data science techniques, because if you have to have a good knowledge, at least a sound knowledge on all those aspects in order to become a good data scientist who can practice machine learning in the real world. Right. Machine learning is so hot. Everyone is talking about machine learning. Everyone wants to do machine learning. Why is that? It is because of we have a lot of data right now. You know, normal the post systems that you have on the Cargills for city or the Keels that you go for shopping, they are generating data day by day. The phone you are using, the mobile phones that you are using today, are generating a lot of data today. And even the refrigerators or the smart devices that you have in your home are also producing data. All of these data goes for some place, maybe a database or the data lake or a data lake house. And using those data in a profitable way is the next big challenge we are having right now. So in order to use those things in a profitable way, machine learning comes pretty handy because it gives so much of insights, plus it gives a lot of power for us to predict the future, which everyone likes. That's why everyone is going for the fortune tellers and all. But this is kind of like fortune telling or future predictions using data and viable situations that we have and that we have seen. Right. So this goes for a bit of theoretical aspects right now. Before that, I want to see if you have any questions, and just I'll give like 30 seconds. You can just ping up in the chat window or anywhere if you have any question. And also, as mentioned in there, you can put the questions in this link by following the link. Kavindi, do we have any questions right now there?
Not yet, Aya.
Cool. So we'll move forward. This is going to be a bit technical, but this is the core or the crust of machine learning, and it would be really good to know when you're going for the next sessions too. Right. So in machine learning, there are two main components. There are many other components too, but I'm only focusing on two main components. The first component is known as supervised learning or supervised machine learning, while the second component is known as unsupervised learning or unsupervised machine learning. Supervised machine learning is widely seen and widely used in the industry, as well as it is so much used in most of the cases. So in supervised machine learning, the privilege that we are having is we are having a labeled data set. Labeled data set means a data set which is having set of labels that we're going to predict in the future. So main two components that we can see in supervised machine learning is classification and regression. So I'm going to explain each of these aspects. So just keep in mind these terms, and we'll discuss in the next slides. So then you'll be so much familiar on those things. Those are two main aspects that we can see on supervised learning. When it comes to the unsupervised machine learning, we don't have the privilege of having any labeled data. So we don't have any labeled data, but we are finding out the relationships between those data without the labels. So one of the major aspects or the approaches that we have seen in unsupervised learning is clustering. So we'll move forward and see what actually these terms are, because these are the main areas in machine learning that you can think of and that you can solve your problems with. Right. So in supervised machine learning, as I said previously, we have the privilege of having a labeled data set. So label data set means for each data point that we have a label. So in this example that I have took, we have set of images here, and each image is labeled saying if it is a duck or if it is not a duck, right? So what the supervised learning is doing, they can build a predictive model in order to identify the ducks and images which are not ducks by using a supervised machine learning problem, right? When it comes to unsupervised learning, we don't have the we have the power of having the labels. In unsupervised learning, we only have the images or the data points, and we have to find the relationship between all those things and have to make sure what our prediction is from those unlabeled data. So that is the main difference between those two, supervised learning and unsupervised learning, right? So in my previous slide, in this slide, I told you about classification, regression, and clustering, which are, we can say, the main components in machine learning, the things that we can solve with machine learning. So we'll do like this. We'll say you have any problem that you think or you assume that you can solve from machine learning, and think from your mind or think from your head whether the problem is coming out for any of these categories, and then obviously that is the way to go forward with that particular problem, and that is the machine learning approach that you have to take, right? Classification algorithms or the classification machine learning problems, that is very simple. It is classifying whether it is A and B. So we'll say you have set of images of cats, we'll say 1,000 images of cats and 1,000 images of dogs, and you have jumbled all those images together, and you need to build a model or a machine learning model that can divide those cats and dogs. So obviously, we'll say those images are having labels. Then the machine learning approach that you have to take is classification. What you have to do is you have to make those into the groups based on the labels and the relationships that they are having with those data points. So if it is only two classes, we normally tell that is a binary classifier. If it is more than two classes, we normally take that as a multi-class classifier. So simple as that, telling whether it is A or B or C. So the next type of classification, kind of like an extend version of classification, is anomaly detection. Anomaly detection is finding who's the weird one. We'll say you have a production line in a factory which produces some toys, and you need to find out the toys with defects. So we'll say you get an image of the toys and tell a machine or a computer to identify the faulty things. So in those cases, the machine learning approach that you have to take is anomaly detection, finding which is the odd man or which is the odd one. This is kind of like classification, but the main difference is when it comes to anomaly detection, the anomalies or the faulties that we have is very less in number compared to the good ones that we have on that set, right? That is about classification and anomaly detection. And then we goes for the next most important thing, regression. So I'm pretty sure you have done your O-level mathematics. In O-level mathematics, we know the equation of y equals mx plus c, which is the equation of a simple line. So it is the simple linear regression. If you know the value of x, we can tell the value of y. So starting from those linear relationships, we can go for non-linear relationships, which is more complex. So that goes for the regression algorithms. So with the regression algorithms, we can predict or we can tell the future about how much or how many. That is going to give you a numerical value. We'll say you need to predict the temperature of next Wednesday, or we'll say you need to predict the price of a car based on the features that car is having. So those are the things that you can solve from regression algorithms or the regression machine learning approach. So that keeps all in the supervised way, or the supervised way of doing machine learning. And when it comes to clustering, or the problem that say how is this organized, that comes more into the unsupervised machine learning manners. In this case, we don't have the ability of having, or the privilege of having, labeled data set. This is only having the data. So what we do is we take the relationship between these data, the similarities and the differences between these data, and we classify based on those things, those similarities and the differences. So those things are called clustering algorithms. We'll say we have set of flowers without any labels. We only have the images of those flowers, and we need to classify those flowers, or the cluster those flowers based on their appearance, their color, their size, and those things. So that goes for a clustering problem in machine learning. Sorry. So the next approach is pretty popular right now, mostly with the robotics. So this is reinforcement learning. This is the way of learning as a human. So in this way, think of this thing. We'll say you have a kid, just 1 year old, and you show the kid a crow. On the first day, you show the kid a crow and tell, hey, we'll say the kid's name is Saman, and you say, Saman, that's a crow. And first day, he just see the crow, a black bird, that's it. And the second day, you show him another crow and say, Saman, that's a crow too. And on the third day, you show another crow who's crawling down from your window and tell Saman, that's a crow. And in the fourth day, when someone sees a crow, a bird which is having a black out feathers and with a black beak and all in that particular size, like someone will tell, all right, that's a crow, based on the experiences that they had. So that is the main idea behind reinforcement learning. It is giving like if the model is not predicting the correct things, so it will give a bounty, and if it is giving a correct output or correct prediction, it will give a reward. That's how the reinforcement learning algorithms are learning. This is mostly used in robotics right now. So we talked about clustering, we talked about classification, we talked about anomaly detection, and we talked about the things like reinforcement learning. In order to do these kind of things, we have a lot of algorithms. So for an example, in order to do classification, we have more classification algorithms like decision trees, decision forest, naive bias, or maybe artificial neural networks, the things like that. There are many algorithms that we can use for classification. So the next problem that comes to your head would be how to find out which algorithm which will suit for my data set. That is based on the number of data, and that is based on the shape of the data that you're having, plus that is based on the practical scenario that you're going to solve on. And you might have to go with the trial and error scenario to figure out what is the best algorithms to go forward with your data for your modeling. So there are plenty of algorithms out there which you may have to use and you may have to learn in order to practice machine learning. So that is about the theories, and bit more theories. I guess this is not going to be boring. So we talked about artificial neurons, which is one of the major aspects that we talking about today. So as I said previously, this is widely used in computer vision and natural language processing. What it does is it is mimicking how our human brain is working. So it is having set of neurons, artificial neurons in layers. And what it does is it learns the patterns that the data is having, and they store as weights and biases in these networks. After training the network with thousands or 10,000s of images, when we have a test set or a practical scenario, we have to cluster, we have to predict the things. The neural network is capable of predicting the next upcoming event with the experiences or the weight and biases they have saved in the network. Right. As I said previously, neural network is not a black box. So that is one of the major things that you have to keep in your mind. That is not a black box. It's a simple mathematical equation. I'm not going to go forward because I'm pretty sure like most of the guys here don't like mathematics. Might be, I don't know. So, but yeah. So it is a simple mathematical equation. And even the deep neural networks that we can see here is a composite of that chunk, like small chunks of that simple mathematical equation that goes as a deep neural network. So this slide, just a simple introduction about like why, what is the difference between normal neural networks and a deep neural network that we can see on deep learning. So when it comes to a deep neural network, it is something like a deep pan pizza, which is having some tasty stuff in between. When it comes to the vanilla neural network or a simple neural network, it is just like a thin crust pizza, which is having very thin crust, the input layers and one or two middle layers and only one output layer kind of thing. So that is all about neural networks and the difference between normal neural networks and the deep neural networks. Deep neural networks are so much tastier than the normal vanilla neural networks. Right. Because of this ability of learning that non-linearity with those neural networks, they are widely used in computer vision and also in natural language processing. So you may have seen the autonomous cars and the things, they use neural networks. You may have seen the GPT-3 and the language understanding models or the chatbots that we are using today. So all of those things are using some sort of neural networks in order to do their predictions or their image processing kind of tasks. All right, that is all about the theories and what you have to know and the things that we can do with machine learning and all, because you obviously know what to do and how to like what to do and what we can do with ML. The next question you will ask is how to start. I want to be a machine learning professional or I want to be a data scientist. How to get started? So let's get started on this way. So fun fact, in order to become a machine learning engineer or a data scientist, definitely you need to know a programming language. So I would suggest to go forward with R or Python because that is the most used languages right now. Personally, I'm much more familiar with Python and it is more widely used than R now. R is more like in the statistical space yet. Python is becoming so much popular in this machine learning space. So start with Python or R. I would recommend Python. So first things first, learn Python. And then the next thing is to know or get yourself familiar with some of the libraries that you have in machine learning space, starting from the simple NumPy and scikit-learn. It goes for matplotlib, which we use for visualizations, and the pandas kind of things that we use for data frames, and the things like Jupyter notebooks, which we use as the development or the IDE that we do the machine learning things and all. And if you want to go forward with deep learning, if you want to like do some calculations or the experiments with computer vision and NLP and kind of things, then obviously you need to know a deep learning frameworks. So TensorFlow by Google is one of the most popular deep learning frameworks out there in the market. And also we have Keras with that, that comes with TensorFlow 2.0 also like integrated, plus PyTorch, which is the Facebook's framework of deep learning, which is pretty popular. And when it comes to the research space and also in the implementation space, PyTorch is getting so much popular. I would say PyTorch is a bit more easier than TensorFlow because I have been using PyTorch for a while. So it is pretty easy. So other libraries like CNTK, Torch, Cafe, and those things are not that much popular right now. Even CNTK is retired right now from Microsoft. So TensorFlow and PyTorch are one of the major dealers when it comes to the deep learning frameworks right now. Right. We talked about the technologies. We talked about like the frameworks and the things. So how to know the theories? We'll say your uni course or you are self-learning the thing. So go online. There are plenty of online resources that you can think of, and you can go forward with. I would rather suggest this course from Stanford, which is comes in Coursera, from Andrew Ng. So this course is pretty good. Andrew Ng's machine learning, one of the most done courses in the online space right now, I guess. So start with that. You will get a good idea about the theories behind machine learning and all. It will give a very good start if you coming into the career of data scientist or machine learning engineer. Apart from these things, you need to know other computer science aspects too. You need to know how to do programming. You need to do how to do database. You need to know how to do a simple web applications. You need to know the simple basics of networking. You need to know the simple basics of cloud computing and using cloud resources in order to do the calculations. You need to know how to work with a Linux machine. So those are the basic stuff that you need to know in order to become a data scientist or a machine learning engineer. All right. So the next part is many people are asking from me from most of the sessions, like we have seen a lot of applications in computer vision. So where it is going to head, where it is going to be end up with, and is it really essential? Is it really doing something? Yes, it is. So as I said previously, autonomous cars is one of the major examples that I can take where computer vision is doing very drastic changes and groundbreaking innovations. And also the things like facial detection and detecting whether the surveillance areas, those are pretty cool areas that computer vision is getting used on. And also if you go for Facebook these days, you might have seen some of the artwork that they have generated from AI. So those things are also coming up as a groundbreaking thing in AI or the machine learning space right now. When it comes to the natural language processing, as I said previously, so information retrieval, sentiment analysis, whether to say good or bad, and question answering that we have seen in chatbots, those are some of the major areas that coming up, and also getting used to use these neural networks in order to do some pretty cool stuff with NLP. So we can say in the future, so these things would be rather more familiar and rather used in more in our industrial applications a lot. Right. So the next thing would be, because I'm pretty sure there are many undergrads in or like people who are doing higher studies are in this particular session. So people may ask, what are the research areas that we have and what is much more interesting happening in AI? Yeah, there's a lot. There's a lot happening in the large text corpuses like BERT and GPT-3 kind of areas. So how to understand natural language. So that is a very good research area that you can work on. Other things like semi-supervised learning, where we only have a particular set of data has been labeled and we need to do semi-supervised learning kind of things. Plus the things like one-shot learning, few-shot learning are some of the key areas that you can research on. GANs, which is pretty interesting, generative adversarial networks. And if you are familiar or if you're interested in edge devices or the IoT devices, how to do AI or how to do computer vision or the NLP in an edge device, which is having small computation power. So those are pretty good research areas to work on. Graph networks with deep learning, yeah, that's another pretty good area to work on. Plus ethical AI, because of this AI hype and the things, people are concerning about the ethics in AI, and people are concerning about the biasness, interpretability, the transparency on AI or the machine learning models. Those are pretty good research areas that you can work on if you're interested in research arena of this machine learning space. Right. Last but not least, so I'm going to put your mind into the career, like, some of the theories behind machine learning, what you have to learn in order to get into the career of machine learning and deep learning or in data science. So you may wonder, are they actually using in the practical applications? Yes, it is. So these two are the experiences that I have from my career from after my bachelor's. So I have been working as a software engineer in data science and analytics back in Sri Lanka. At that time, we were doing document processing, document management for the company I used to work for. In that company, we had a mobile application where we had to like scan a document and see what text that document is having, or like whether this document is a driver's license or whether this document is a birth certificate. We had to do that thing from our mobile application. So if you just go for internet and search cognitive services, you can see just APIs that you can use just by putting a JSON in and getting a JSON out, and can do that kind of things from your mobile application too, by using just AI powers without doing any coding, but you can just use as an API. So those are pretty cool industrial applications. So starting from simple mobile applications where you're using just API calls, right now with the AIS, we are developing models to understand human motions. So understanding how the players are moving in the playground and building strategies for them based on their player poses and the human motions. So that's what we are doing. Starting from that simple text analysis or text detection kind of thing, we are moving forward more for like a getting competitive advantage in a more sophisticated space with AI. So lastly, what I have to emphasize is AI is not a fiction. And if you want to do AI or machine learning, I would strongly suggest you to put your attention on all those three aspects, which is statistics, mathematics, plus computer science and the domain knowledge. Don't forget your computer science. Don't forget your data structures. Don't forget your OOP, because you will absolutely need those things in order to do data science. And if you're going to do data science, don't forget your mathematics. You may need some areas in mathematics in order to be a good data scientist or a machine learning engineer. Don't forget your domain knowledge. Be a real life, like a real human who sees the world in the realistic way. Because other than having a domain knowledge, you can't think of like how the things has been done. For an example, I'll give a simple example. So right now I'm working as a consultant in the data science or the machine learning space. The project that I had before with my company, like 2 weeks before, was with a pretty big franchise. You may know 7-Eleven. In 7-Eleven, the problem they were having was understanding their loyalty program and the thing, like doing some sales analysis for them. So doing such things, you have to have some idea about how normal sales analysis are happening, how normal sales happening in a supermarket space. Those things you need to know. So don't forget your domain knowledge, don't forget your computer science knowledge, and please don't forget your maths too. Those three pillars are really needed in order to be a good machine learning engineer or a data scientist. Cool. That comes to the end of my session. So that is the Q&A time. So do we have any questions out there?
All right, Mr. Haritha, that was an insightful session and a perfect start, a perfect inception rather for the field of artificial intelligence, as well as for the pre-bootcamp of AI-Driven Sri Lanka. And our sincere gratitude goes to you for that fabulous session. And I hope all our participants have gained the fruits of your labor with the interest of the field of study of artificial intelligence. All right, ladies and gentlemen, it's time for your questions in regards to this session conducted. If you have any more questions, please share your question in the Slido link that is shared in the chat. On that note, let's move on to the first question of the first session of the AI-Driven Sri Lanka Pre-Bootcamp. So the first question is, only computer science degree can do, people can do machine learning.
I guess the question is about if it is about like if a person is having a computer science degree, do that person is only can do machine learning? No, it is not. I have seen some people who are having degrees in statistics, or even in other areas like physical science, or maybe in electronics. They do machine learning too. So as I said previously, the main three pillars that you need to know to become a good data scientist or a machine learning engineer is computer science, mathematics, and domain knowledge. So if you have those three aspects in your knowledge, so definitely you can be a machine learning engineer. I have seen a lot of self-taught machine learning engineers who haven't done any computer science degree. So that's not a must.
Right. So hope that question is answered. So we'll be moving on to the second question. What is meant by semi-supervised?
In semi-supervised learning, what we have is, as I said previously, in supervised learning, we have a labeled data set. But in semi-supervised learning, we don't have a fully labeled data set. We'll say you have 1,000 data points that has been labeled, but we'll say we have 2,000 more uh, data that hasn't been labeled but in the same domain. So what we have to do is we have to get the labels for the second set by looking on and doing some analysis on the first set. So that is called semi-supervised learning. One part is labeled and the other part is labeled. It is kind of like a combination of supervised learning and unsupervised learning.
Right. So let's move on to the third question of today's evening. Can you explain the difference of a machine learning engineer and a data scientist?
That's a very good question. So when it comes to the terms that we used in the industry, so this differs from company to company, industry to industry. But the vague idea that I can give, when it comes to a machine learning engineer is more focused on productionalizing these machine learning models, and they are more focused on building the machine learning models in maybe in computer vision or natural language processing kind of tasks, plus making those things available in real world applications by taking care of deployments and the machine learning pipelines and all the things too, like ML ops. They are capable of doing end-to-end machine learning model building. But when it comes to a data scientist, they might not go for that final stage of making the models into the productionalizing, but they will do more modeling aspects of the data rather than going for productionalizing things. So when it comes to a machine learning engineer, definitely you have to know a lot about, we'll say, Kubernetes, Docker, and those things too. But I have seen some data scientists more familiar with more statistical aspects and more data modeling kind of thing, so rather than going forward with that more computer science aspects.
That was a wonderful answer, Mr. Haritha. So let's move on to the next question. Is deep learning dominating the classical machine learning algorithms when it comes to real-world applications?
So when it comes to real world applications, what we have seen is most of the real world applications are non-linear. So interpreting some of these non-linear problems, the classical machine learning algorithms are not that capable of doing those things. So in those cases, they are dominating in the areas like computer vision, natural language processing kind of tasks. But uh, in also real world applications which are not that non-linear, which are not that complex, we can get a good accuracy without uh, wasting a lot of time in model training by using classic machine learning algorithms. Like, we'll say in some cases we have seen decision trees works way better than neural networks in some applications in the real world. So we can't tell those are dominating, but when it comes to this computer vision and NLP kind of areas, yes, deep learning or the deep neural networks are the best.
Hope that question is answered. So let's move on to the next question. What helps you in identifying the correct machine learning algorithms fit for the problem?
Right. In this case, what we normally do is we use the machine learning algorithm, and then we uh, get our evaluation matrices. So that evaluation matrix might be accuracy, maybe recall, or maybe the things like area under curve, or any metrics that we use based on the problem or the domain that we are having. So what we normally do is we do test our data with the models that we have built, simple train test split or train test validation split, and we see how well our ML algorithm is performing with that particular set of data. So in some cases, we can't tell beforehand, right, okay, this data will go forward with decision tree or this data will go with decision forest. We can't tell that beforehand other than just doing experiments and going forward with the trial and error thing.
Right. So let's move on to the next question. What are the skills need to pursue a career in AI and data science?
Right. As I said previously, the main skills that we need is the skills in computer science, your data structure knowledge, database knowledge, the things like that, plus the knowledge in mathematics and statistics, plus machine learning, because I would say in machine learning, there are some theories that you need to know. And obviously the domain or the real world knowledge to apply those things. So I would say if you're moving towards this career in AI and data science, please focus on all these three areas. Don't forget your basics. So you need the basics to go forward with that.
Right. So that was a wonderful answer by Mr. Haritha. So let's move on to the next question. And the question is, what is the connection of machine learning with MATLAB?
Yeah, MATLAB is a pretty dominant software in the mathematics world. But in MATLAB, there's a set of packages. We call those things packages, that or the tool boxes that comes for machine learning. Because MATLAB is capable of doing metrics calculations, which is the base of machine learning. So you can do machine learning modeling or the machine learning model building using MATLAB. I have seen in a lot of scientific research areas and also in the engineering aspects, they use MATLAB rather than going with Python for doing machine learning. The only problem is when it comes to MATLAB, it is a paid software. So you need the license in order to do all those stuff there.
Right. So yes, let's move on to the next question. Unlike other projects, machine learning project outcome is hard to predict. So how to tackle this when planning a machine learning project with timeline and resources?
That's a very good question, because in machine learning projects, we have to think of what is the acceptance criteria. We'll say you have an industrial project that will need a 90% accuracy for some particular prediction. So you need to like pre-hand decide whether you're going to spend 6 months in order to get 90% accuracy, or you're just going to spend 3 months to do 85% accuracy and just keep it as it is. So the first thing you have to do is you have to have some realistic goals, and the next thing is you have to go for some POC model build. That means proof of concept kind of things before going for the big problem solving in order to do the project planning. And the next thing is you need to know your resources, and you need to know what is the time that you're going to put on those things. For an example, I have seen some projects that goes for, we'll say that model goes for accuracy of 90%, and you have to spend 1 more year to get 91%, right? That will be a good thing in research, but it will not good in the industry, because in the industry, time is money. So in the beforehand, you have to think of whether we have to go with the like a monetary benefits that we are getting, or just going for some scientific experiment kind of thing. So you have to decide it by your own.
Right. So that was a quite descriptive answer, and a lot of things to be gained from that. And yeah, let's move on to the next question. What is the demand compare by between software engineer, developer, and data scientist?
So I would say both are very demanding fields. So a general software developer, like not a general software developer, like an experienced software developer is having a lot of demand right now. And also when it comes to the data scientist is the same. I would say we can't deviate both things in two different manners. But because of the lack of good data scientists in the industry, data scientists are having a little bit more demand than software developers right now.
Right. So yes. So let's move on to the next question. Uh, we look at machine learning software almost all time. How do we apply machine learning to hardware?
Right. I'm not totally getting this question. It is, I guess, about the hardware that we use for machine learning calculations. Yes, this is a very good question, if that is the thing. Because in order to do a lot of calculations, definitely we need to have some optimized hardwares that is capable of doing these complex calculations. As I said previously, GPUs is a very good way to go forward with. Plus, we have seen a lot of edge devices or the IoT devices that comes with comes with inbuilt GPUs in that, like Jetson Nano, NVIDIA Jetson Nano kind of instruments. So those are pretty good things to look on when it comes to these IoT and machine learning aspects. Plus FPGAs, field programmable gate arrays, the basic concept after the gates. So FPGAs has been using in machine learning a lot too. If you planning a machine learning model in a critical application, critical software application, definitely you need to think a lot on the hardware aspect too.
Right. So yes, I hope that question is answered. So the last two questions. So the one before last, what are the companies available for data science in Sri Lanka?
This question, I I reckon like most of the companies in Sri Lanka is doing data science, at least doing some parts of the data science with and machine learning right now. I have seen some companies out there doing just analytics stuff even. So there I have seen I can't say the names, but I have seen some companies they are doing uh, just analytics, and they do all of their data related stuff only. So I would say most of the software companies as well as other franchises or like non-IT companies are focused on data science and analytics right now.
Yes, Mr. Haritha. So we would love to continue Q&A session, but time is a constraint. So this would be the last question of today's evening. Is it possible to use KNN for image processing?
Yes, you can like KNN is like a clustering algorithm. Yes, in some cases, KNN can be used for image processing or computer vision tasks. So I have used KNN in one of my application. In order, I had a question or like a problem to identify players in a playground by their shirt color or the jersey color. In that case, I used KNN in order to like cluster the players. So yeah, there are many aspects that you can use in KNN and those algorithms where you can use in image processing or the computer vision.
Yes. So we have got one question at the last moment of the today's session. Does deep learning require high-end NVIDIA?
Yes, I got the question there. So the question is, does deep learning require high-end NVIDIA graphic card with huge VRAM? So this is the case. When it comes to deep learning is all about uh, thousands or millions of small calculations, metrics calculations. In order to do such thing, we need to have a lot of parallel processing power. When it comes to a CPU that we have in our computer or laptop, they might have three physical ROMs, physical processors, or four physical processors, might be five or six in a high-end CPU. But when it comes to a GPU or an NVIDIA graphics card, we have hundreds or the thousands of processors. So for an example, the NVIDIA 940MX, the graphic card that you have in most of the laptops, they are having 384 CUDA cores. CUDA cores means small processors, small physical processors. So compared to a CPU, you can do 300 more calculations, like 380 more calculations from a GPU. That's why you need NVIDIA graphic cards in order to do deep learning calculations. Right now, I know like NVIDIA and the other manufacturer, Redon, is having graphic cards, but the deep learning frameworks right now we have like TensorFlow or PyTorch is much more supportive for NVIDIA. I don't know why, because of they are having CUDA framework that has been developed by NVIDIA. So obviously for doing deep learning, we might have to use their graphic cards.
Right. So on that note, ladies and gentlemen, we shall conclude our Q&A session, and with that, the first workshop as well. So I'd like to thank Mr. Haritha Thilakarathne for taking his time under a busy schedule and join this evening for our inaugural session. And I hope his knowledge has helped all of our young participants to gain some much needed help to their academic additions. Thank you once again, sir, for your most valuable time, and we would like to present this token of appreciation on behalf of the organizing committee of AI-Driven Sri Lanka.
Thank you. Thank you for inviting me for this awesome session, and hope your bootcamp will be a success in the future too. Thank you.
Thank you very much, sir. So to mark this moment as a memorable event, I invite all our participants to turn on their cameras to take a snapshot. Let's wait a couple of seconds until all turn up the cameras. All right, so I'll give a count of 3. So give your best cheers. 3, 2, 1. All right, so that was it, the snapshot. And thank you very much to all our participants for joining us for this session. And we hope you have gained some much needed pointers and knowledge. And we hope you enjoyed the session. And please join us in the future for the upcoming sessions that will be held for the pre-bootcamp of AI-Driven Sri Lanka. Join us next time on our second session about deep learning that will be happening on 10th of September. And with that, we would like to wish you a very good night and have a happy journey with AI-Driven Sri Lanka. Signing off.